All right, let's dive into one of the most fundamental shapes in all of geometry, the cube. Today, we're going to break down two really key ideas, surface area and volume, and you're going to see just how simple and actually how powerful these concepts really are.
I mean, have you ever actually wondered about this? When you're wrapping a gift, how much paper do you need? Or when you're packing a box, will everything fit? Well, these everyday questions, they get right to the heart of what we're talking about. Surface area and volume are the tools we use to figure this stuff out. It's pretty cool, right?
So let's start with the star of our show, the cube itself. I call it the perfect box because its incredible simplicity and symmetry make it the perfect place to start when you're trying to understand three-dimensional space.
So what is a cube? Officially? Well, it's all about those 6 perfectly equal square faces. Every single angle is a perfect right angle, and every side is the exact same length. It's this perfect symmetry that makes all the math behind it so clean and, honestly, so satisfying.
Okay, so here's what you really need to lock in. A cube has 6 identical faces, and all of its sides are the same length. For the rest of this, we're just going to call that side length A. And believe me, that one little letter A is the key to unlocking everything else.
First up, let's talk about surface area. The easiest way to think about this is to imagine it's the total skin of the cube. You know, it's the part you can actually touch, the part you could paint, or the part you'd cover with wrapping paper. To figure out the area of the entire surface, let's not get ahead of ourselves. Let's just start with one single, flat, square face. Now, you probably remember that the area of any square is just its side length times itself. So for our cube, the area of just one face is A times A, which we write as A squared. Simple enough, right?
And you see how this builds so logically. It's not some formula you have to just memorize out of thin air. We start with the area of that one face, which we know is A squared. Then we just remember, wait, a cube has 6 of those identical faces. So the last step is super simple. You just multiply that single area by 6. That's it.
And there you have it. That's the official formula. The surface area of any cube is just 6 times A squared. It's elegant, it's simple, and it's built on a logic that just makes sense.
Okay, theory is great, but let's make this real. Let's say you've got a little gift box, and each side, that's our A, is exactly 5 centimeters long. So how much wrapping paper would you need to cover it completely, with no overlap?
We just plug that 5 right into our formula. So the surface area is 6 times 5 squared. First, we do the exponent. 5 squared is 25. Then we multiply that by 6, and we get 150. Now, pay close attention to the units. It's centimeters squared. That little 2 is a huge clue that we're measuring a flat, 2-dimensional area.
Okay, so we've totally wrapped the outside of our cube. Now, let's shift gears and move to the inside. We're going to figure out how much space is inside the cube. And that, my friends, brings us to the concept of volume.
So what is volume really? It's just a measure of capacity. How much can something hold? The general formula that works for any boxy shape is just multiplying its 3 main dimensions, the length, the width, and the height.
But, of course, for a perfect cube, it gets even easier because the length, the width, and the height are all the exact same thing. They're all A. Our formula just becomes A times A times A. Or, to write it more elegantly, A cubed.
All right, time to put this new formula to the test. Let's imagine a different cube, a smaller one this time, where each side is 3 centimeters long. The question is, how much water, or sand, or sugar could we fit inside this little guy?
Okay, so we take our side length of 3 and we plug it into the volume formula. That gives us 3 cubed. So 3 times 3 is 9, times 3 again is 27. And look, the units have changed. It's now centimeters cubed. That little 3 is our signal that we're now measuring a 3-dimensional space, the actual volume inside.
Now that we've seen both of these concepts in action, let's put them right next to each other, head to head. Because honestly, really understanding the difference between them is the most important takeaway of all.
This side-by-side comparison makes it all so clear. Over on the left, with surface area, we're thinking in 2 dimensions, like we're painting a flat surface. That's why we use A squared. But on the right, with volume, we're thinking in 3 dimensions, the actual space inside the object. That's why we use A cubed. See? They answer totally different questions, and they each have their own unique formula and units. If you only remember one thing from this whole explainer, Let it be this right here. Surface area tells you how much paint you need for the outside. Volume tells you how much water it can hold on the inside. It's a perfect, super simple way to keep them straight in your head.
So let's just do a super quick recap. Surface area, that's all about the outside, the sum of all 6 faces calculated with 6a squared. Volume, that's the space on the inside, calculated with a cubed. And please, never forget the units. Squared for area, cubed for volume. That tiny little number tells a huge story about what you're actually measuring.
And I'll leave you with a final thought to chew on, or maybe to chill on. Imagine a company that ships ice. To keep that ice from melting as long as possible, what should they focus on? Minimizing the ice block's surface area or its volume? It's a real-world problem where understanding these two concepts makes all the difference. Think about it.